Hello, everyone, and thank you for joining this webinar. My name is Ash Musa, and I'm a product marketer on the Bitbucket Cloud team. In this webinar, we have two senior developers from the Bitbucket Pipelines team who will walk you through how they use Bitbucket Cloud in their development workflow. Who is this webinar for? If you're a developer looking to learn more about using Bitbucket Cloud, or if you're a Bitbucket server or data center customer, evaluating if Bitbucket Cloud is right for your team, this webinar is for you. In today's webinar, we have Nathan Burrell, who is a principal developer and a founding member of the Bitbucket Pipelines team. He's been on the team for 8 years and has led major initiatives such as migrating pipelines from ECS to Kubernetes and redesigning our runner to execute on self-hosted hardware. He's currently focusing on developing new pipelines features to support enterprise customers and building a new integration framework for Bitbucket Cloud. And we have Graham Gatiss, who is a senior DevOps engineer who focuses on maintaining release pipelines. His background is in Java development, and he's managed complex CI/CD workflows across both Bamboo and Bitbucket pipelines. At Atlassian, over 6,000 developers use Bitbucket Cloud to build their own tools. In this webinar, Nathan and Graham are going to walk you through how their team uses Bitbucket Cloud for code review and, of course, how they structure their deployment workflow in Bitbucket pipelines. So before we begin, a little bit of housekeeping. If you have questions during the webinar, please use the Q&A console on your webinar screen. After the webinar, we'll have a live Q&A with the speakers. And this comes up a lot. A few days after the webinar, you will get an email with the webinar recording and all the resource links that you see on your screen as well. So with that, I'm going to hand it over to Nathan.
Thanks, Ash. Let's go over what is coming up in the talk. First, we'll talk about how we use Bitbucket Cloud to ensure quality code using Jira and merge checks. Then we'll talk about how we use Bitbucket pipelines to ship high quality code fast by covering how we use YAML features to your advantage to change the defaults, using different pipelines for different purposes, using different features of pipelines to ship quality code, such as reusing YAML, the triggers, our new stages features, pipes, OIDC, how to share configuration, services, and authentication. And finally, we'll talk about how we use Bitbucket pipelines to deploy our code, such as using its tracking features, deployment previews, how we do redeploys, and deployment permissions. First, let's share a little bit of information about our team. Bitbucket pipelines is a feature of Bitbucket Cloud that provides continuous integration and delivery services for teams of any size. Our team consists of multiple developers split across 3 separate teams, focusing just on CI and CD. We maintain 18 microservices, 40 libraries, and 2 applications, all running on AWS, managed via our internal PaaS Micros. We also have 10 separate Kubernetes clusters spread out amongst various regions, which execute all the steps. All of our services are deployed to 3 separate environments, development, staging, and production, and these are deployed to multiple times a day. Let's discuss now how we track that work by using Bitbucket and Jira. Jira has a feature called the Dev panel pictured in the slide. This panel contains information related to the ticket and is populated from your various SCM and CI/CD processes, such as pull requests, builds, and deployments. This information is linked to Jira using the Jira issue key. The way our team uses this is our workspace admin has linked our Jira instance to Bitbucket Cloud. Now all we have to do is place the Jira issue key into the branch name and the commit message. Having it in both is the best way to ensure all information related to pull requests, builds, and deployments is automatically sent through to Jira. By placing it in the branch name, any PRs you raise will now have it automatically added to the PR title, linking the pull request to the Jira issue. And any pipelines associated with commits on this branch will now have their results automatically pushed through to Jira. If you set the commit message to also include the Jira issue key, any deployments made containing the commits will also be pushed through to Jira. This is a great way to share information with managers, support, designers, and any other people on your team who are watching Jira issues rather than performing development day to day. They can now see where the code is up to as part of its lifecycle, such as in development, in review, or deployed to production. Now that we have discussed how we can get information from Bitbucket into Jira, we'll talk about how we keep the quality bar high at Atlassian and how we encourage peer review and development by using pull requests and merge checks. Pull requests are a great way of ensuring high quality code by consistency and peer review. The way development works at Atlassian is each developer creates a branch off of main to work on their feature in isolation. They then make 1 or more commits to this branch as part of development, and eventually it is ready for review. And it is at this point that they then open a pull request to ask if this code can be merged to main to have it eventually go to production. This is where other developers on the team can guide the code by checking for the correctness of logic, usage of patterns, test quality, etc. Part of this process is also automated in that we also use merge checks so that not only do we enforce code is reviewed, but all code has to have certain conditions applied to it before it can be merged. Merge checks are a policy control mechanism that disallow merging code to particular branches unless certain conditions are met. Some of the conditions we use in our team are the minimum number of approvers. That ensures that we have other developers review each other's code. No unresolved pull request tasks, so that any actions agreed to be followed up on from the feedback on the PR action. The minimum number of successful builds set to 1 to ensure that each change has code that compiles and passes the existing test suite. We also reset approvals whenever the source branch is modified, so that all new code added to the branch is reviewed. And finally, we don't allow merging at all without any of the above bit not being satisfied. Pull requests and merge checks are extremely useful as well for certain compliance requirements, such as SOX, where we must have all code reviewed by at least one other engineer and have a green build before it can be deployed to production, ensuring all code is compliant, secure, and correct. I'll now hand you over to Graham, who's going to talk about how we structure our pipeline for maximum reusability.
Thanks, Nathan. So when it comes to structuring YAML, a feature we use fairly frequently is YAML anchors and references. Now, these allow us to extract repeated patterns in our pipeline's YAML definitions into reusable components and later reference them where needed. A reference is created by suffixing a YAML item, such as a step, with an ampersand and a reference name. When referencing anchors, you can either reference the item directly using the star operator or merge the keys of the item with some local overrides using a merge operator. In the example here, we've referenced some steps. We keep these steps inside our pipeline's definition section of the YAML and reference them later on. Using anchors and references allows us to easily make changes to a block of YAML which repeats itself. In the example here, we deploy our service to several environments and run post-deployment tests after deployment. And we factor these out into common steps. We factored out these common steps into reusable blocks of YAML. Pipeline Services feature lets you start up additional Docker containers alongside the main build container. These containers communicate over a shared network layer and allow you to bring up any supporting services that you might need. For our builds, we're usually either building Docker images or starting up containers as part of our unit and integration test. So we take advantage of being able to allocate different memory to services, which we've done inside the definition section of the YAML. Here, we've created two different configurations for the Docker service. By default, the service gets 1 gig of memory. And in our example pipeline definition, we defined a small Docker with 1 gig and a large Docker, which we use in a 2x step with 6 gig of memory. We use the large Docker service to bring up many dependencies using Docker Compose. In our tests, we often need to bring up some of the Amazon services such as SNS, SQS, Elasticsearch, DynamoDB, and S3. To improve the speed of pipelines, we use a caches feature, which allows us to cache third-party dependencies and other ephemeral data. Pipelines comes with some predefined caches for most of the popular dependency management systems, for example, Maven, NPM, and pip, and you can also define your own custom caches. To define custom caches, you again use a pipeline's definition section, and this is what we've done here for our Maven cache. So yeah, again, we use definition section to define a cache, and we later reference that cache inside the caches section of any steps that need to use that cache. In pipelines, every step is executed inside of a Docker container, which can be controlled by specifying an image. A default image is available. However, we choose to override this, and we use an image with all the necessary utilities we need pre-installed for the task at hand. In the example here, we specified an image at the top level of our YAML, and this controls the default image used for every step. We've also overridden this image where required at the step level. In this example, we have a deployment step that needs AWS CLI, and so we've overridden the image with the Amazon CLI image. I'll now hand you back to Nathan, who will discuss various pipeline types.
Thanks, Graham. Over the next few slides, I'm going to discuss the various pipelines type we use. The first pipeline we use is the default pipeline. This is used as a fallback for when a less specific pipeline is matched, and a great way to ensure every feature branch uses the same pipeline regardless of your branch naming strategy. The default pipeline for pipelines simply runs our unit and integration tests. As pipelines as a CI/CD product, we invest heavily in automated testing to ensure all changes can be delivered as fast as possible at all hours of the day and automatically to customers. We write and run unit tests against each and every class in a service or library, and these make up the majority of our tests. These mostly utilize mocking to mock out our dependencies. The next layer up is the integration tests. These are against each public entry point to a service or library, such as HTTP resources, events, and public interfaces. These utilize local fakes and mocks to mock out their dependencies. These two layers of tests are run on each developer's machine as part of their development, and as part of all of our pipelines used for all of our branch builds. Development-wise, these are cheap to medium to implement and maintain. This is used in conjunction with merge checks discussed previously to ensure all changes are reviewed and pass our quality and correctness standards before it can be merged. As mentioned previously, pipelines uses feature branches for all feature development. The other two main branches developers contribute to are our main branch and our development branch. These pipelines use different workflows. First, let's talk about our most important branch, main. All changes to main have to go through our pull request process as discussed previously. Once a pull request is merged to main, the main pipeline then runs. Before we talk about the structure, let's first talk about stages, a new pipelines feature we've been using internally and we're releasing in the near future. Stages are a way to logically group steps together within a pipeline to be run together and to allow rerunning only certain parts of the pipeline if they fail. They also now allow us to build new functionality around the stage. One such piece of functionality is the deployment lock each environment has. Previously, the lock was only acquired and held whilst a single deployment step ran. Now the lock is acquired for the entire stage and only released once all the steps are completed successfully or if one fails. In the future, other features will be built around this, such as the ability to skip entire stages based on conditions. The way we use this in pipelines is to create a stage for our different environments, such as staging and production. We break up each of the staging and production stage into two separate steps. The first step deploys the Docker container to the environment, and the second step runs our tests. By breaking this into two separate related but logically distinct steps, now if the tests are flaky and fail, we can simply rerun just the test step and not the deployment. This saves us valuable time in our release pipeline when rolling out or redeploying changes. Let's now discuss the entire pipeline we use for main. This has 5 steps split into 3 logical stages, which all run automatically on merge. The first stage simply builds the artifact to be deployed. This runs all our unit integration tests as discussed, and if successful, it increments the release number and pushes that back to the branch, and then it pushes the Docker image containing the service for services or the Jira library for libraries to Artifactory, and then the second stage then runs. This second stage then deploys to our staging environment, adding any new resources we require via our PaaS micros. It then runs our acceptance tests, which test all the major functionality of pipelines, and our browser tests testing our UI. The tests here are our final layer of testing. We call these our end-to-end tests. Other people call them post-deployment verification or acceptance tests. We have more than 50 of these for each major piece of functionality in pipelines. These run as part of our release pipeline after we deploy to staging and act as a gate to production. And we also run these after we deploy to production, and these act as an alert to us breaking anything just after a deployment. We also run these on a schedule to detect any errors in production. These don't use any mocks and all use the same functionality, just automated the same way you would. These are run by pushing code, making REST calls, or clicking buttons in the UI. As part of implementing features, we write test scripts, which we then use to run manual blitzes by the whole development team before they're released to customers. Once the feature gets closer to release, we convert these scripts to an end-to-end test so that they can be run automatically against future deployments. This is how we build trust in our pipeline and practice continuous integration and delivery. If these steps pass, the final stage is then run, which, much like the previous one, deploys our code now to production, adding any new resources via our PaaS micros, and then running the acceptance test for the final time. Now, if anything fails along the way, the build is halted and a developer is notified that the changes are broken, and they can either rerun or redeploy if it's a flake, or roll back their code and trigger a new deployment if it's an actual issue. However, most of our changes make it through this pipeline, as we use feature flags heavily to deploy most of our new functionality. We test this staging and production against a small cohort of then internal and then external repositories with progressive rollouts. Next, let's discuss another important branch, development. Bitbucket Pipelines is a complex product consisting of a cluster of microservices. One way to help developers develop and test out new changes quickly is we run a development environment of pipelines containing test repositories that developers can deploy their changes to without merging to main to quickly iterate on new ideas. Developers simply merge their branches to development. The first step runs the unit integration test and produces a Docker container and deploys it to the development environment. The second step then deploys that image. Now, as developers merge logic to this branch, we need a way to ensure that it doesn't miss out on other changes that occur to main that aren't merged to development. or that the temporary changes that developers have merged into development don't become stale. How we do this is we have a custom pipeline that is set up on a schedule to reset the development branch to main each night whilst developers are offline. This removes any changes made in the last day and deploys any new code from main to development, and this ensures each day we have a fresh development environment. The final feature I want to talk about in regards to how pipelines are triggered is skip CI. As we make changes and push to our branches, such as main development feature branches, there are some changes, however, we don't want to run pipelines for. One such change is our version bumps that I mentioned previously. Whenever we release a new change to production, we want to ensure we push a version number back, but we don't want to trigger a new release when this happens, as it would infinitely recurse. How we solve this problem is to include in the version release commit message skip CI. This can be anywhere in the commit message, and the presence of this skips any pipelines from running for that particular commit. I'll now hand you back over to Graham, who will talk about the various features in our pipeline stage and steps we use when testing and deploying our code.
Thanks, Nathan. We use pipes, which are common CI/CD workflows encapsulated into a plug-and-play style component to simplify some of the common tasks in our pipelines. There are many off-the-shelf pipes available to integrate into your workflows, or you can build your own. The first pipe we use is a custom pipe we've built to authenticate with our artifact storage system, Artifactory. The pipe, which is called the Artifactory Sidekick, authenticates with Artifactory and allows us to seamlessly push and pull Maven artifacts and Docker images. We use another pipe, which sends an event to SignalFx, a monitoring system, after we successfully deployed a service. This is useful as it allows us to visually correlate changes in our application metrics, things such as error rates, HTTP 500s, event queue failures, and alerts with a deployment event. For alerting, we use Opsgenie, and if an alert fires, we were able to use the deployment events, which is sent by the SignalFx pipe, to quickly find what has changed. Here's a screenshot of one of our SignalFx charts. The plot lines represent rates of errors, and the diamond markers just below are deployment events sent using a pipe. We can see in this example here that there's been an increase in errors, and it corresponds with a deployment event. To ensure we aren't shipping vulnerabilities to production, we perform security scanning using SNCC. In this example is a step for the main branch of our runner project, where we're using a SNCC pipe to scan Docker containers produced by the step. Where SNCC detects a high severity vulnerability, the pipe will return an error, which causes the step to fail, preventing later deployment steps from running. Now, we also run this pipe on feature branches to prevent devs committing any security vulnerabilities back to master. So next we'll talk about OpenID Connect, or OIDC for short, which is an identity layer based on OAuth 2 that allows seamless authentication between pipelines and various cloud providers. So in our case, we use OIDC to authenticate with AWS, which avoids the needs for us to manage secrets ourselves. Now, prior to using OIDC, we were using AWS access keys, and these had to be stored as secure pipelines variables. Now, storing credentials as variables has some disadvantages. If credentials need to be rotated, for example, in the event of a security breach or for compliance reasons, then they need to be manually rotated out. And this can often be a time-consuming and error-prone process and often results in broken builds. With OIDC, we are able to establish a trust relationship between AWS and pipelines, which eliminates the need to manage keys ourselves. So in this example here, we're setting the OIDC flag to true. When a step runs, it will generate an OIDC token, which we can use to authenticate with a remote service, which in this case is AWS. So our script here is creating a Docker image, which we then push to Amazon ECR, which is Amazon's container registry, using the OIDC token. Here again, we're also using a pipe, the Artifactory Sidekick pipe, and we're using this to authenticate to our own Docker registry, and then later push that same image, which we push to Amazon, to our own registry for redundancy purposes. Now, to keep our pipeline YAML files simple, reduce duplication, and make maintaining our release scripts easy, we've moved a lot of our common scripts and tasks into their own repository. Many of our pipelines follow the same pattern, which makes a lot of these common steps good candidates for deduplication. When running a pipeline that performs a release and a deployment of one of our services, we need to pull down this shared repository so that the scripts can be invoked from our pipeline. Now, to do this, we're using Bitbucket SSH keys and access keys feature, which allows us to set up read-only access from one repository to another. By using this, pipelines can clone another repository without us having to configure authentication ourselves. For each of our pipelines projects, we've set up a public-private key pair in Bitbucket. When running a pipeline, this key pair is made available under the SSH directory, and we've granted access for that key pair to have read-only access to the pipeline's release project, which is a project containing a lot of our shared common scripts and other auxiliary repositories that we might need to claim. We also use SSH keys to commit back to our repositories. We use a separate SSH key stored as a deployment variable in a base64 encoded form and belonging to a bot user, which will wire up into place before having to commit back. You can commit back without doing this. However, we have controls around who is allowed to commit back to a branch, and so we need an SSH key that's set up and associated with a bot user. As you can see in our configuration here, we stored SSH key as a deployment variable, and we've configured branch permissions to allow only the bot to commit back to main. We've also run a script inside the pipeline to configure Git to push back over SSH using the key. Now, by using a combination of branch permissions, bot users, and SSH keys to commit back, we can control who is allowed to commit back to the main branch. For a defensive depth strategy, we've enabled IP allow listing for our Bitbucket instance. This allows access to Bitbucket only from devices under Atlassian's control and that are attached to our VPN and internal networks. If you wish to restrict access or to allow access to your systems from Bitbucket pipelines, a full list of Bitbucket outbound IPs is published in the support documentation and also available in JSON format. And this information can be used to open up ports on firewalls to allow access into your systems from builds running in pipelines. So self-hosted runners is another feature we take advantage of. Now, runners allow you to run your own pipelines on your own infrastructure with full access to the underlying hardware. We have support for Linux, Docker, Windows, and macOS runners. And steps running on self-hosted runners can be combined with cloud steps, allowing for multi-platform hybrid workflows. The way the self-hosted runner works really well is that if you have an application that needs to be built and tested across multiple different platforms, which is something we take advantage of in our team. Now, in our case, the self-hosted runner itself is a multi-platform application, and we have a requirement to run tests for each supported platform as there are differences between all the various implementations. So as an example, the Windows runner uses PowerShell to execute build scripts, and on Linux, there are differences in how the runner works when it's running on top of Docker versus running in Bash. So for each of these scenarios, we need to run platform-specific tests that run in their own respective native environments, which a runner is capable of. To build and test the self-hosted runner project, we use a hybrid runners cloud approach. So we run and maintain a small fleet of macOS and Windows machines that are hosting runners. And in the pipeline here, you can see an example where in parallel, we've defined steps that build and test the runner across macOS, Linux, and Windows, and execute different scripts for each platform. So to maintain a fleet of runner instances, we use custom pipelines, which we trigger on a schedule. These pipelines are responsible for various housekeeping tasks, such as keeping the EC2 instances up to date and deploying the latest versions of the runner onto those instances. So you can see here we have several of these pipelines which are responsible for upgrading our EC2 fleet. Now, some of these steps can get quite complex. And on the next slide, you will see that we're using various pipelines features, including OIDC, YAML anchors, services, images, pipes, etc. In this step here, we're configuring the AWS CLI to use OIDC. We're using CloudFormation to tear down our old runners and bring up a new fleet of runners via CloudFormation pipe. All right, so I'll now hand you back to Nathan, who will talk about deployments.
Thanks, Graham. Deployments are a feature of pipelines that allow you to track where your code is and ensuring the right code is deployed to your environments. And they also give you control over who can deploy and from what branches. The first part of deployments is tracking. So let's start there. Deployment tracking allows us to visualize our environments as places where code can be placed. Tracking then allows us to then associate a deployment, which is the act of placing code onto an environment, with the environment as a list of changes over time. This allows developers and managers to see where code is in relation to environments and allows supports and ops engineers to see what changes have been recently deployed when trying to diagnose errors in environments. Tracking is started by adding a deployment setting to a step, as in this example here. And that indicates which particular step needs to deploy to which particular environment. When a step is chosen for execution, before it can run, it needs to acquire the lock for the environment. If it can acquire the lock, the step runs. If it cannot, it is halted, and this allows the user to choose which and when steps to resume based on their release order. The lock is then released once the step finishes executing, either successfully or failed. Pipelines uses this feature to track deployments to staging in production. However, one interesting use case is we also use it for the release step to give us an exclusive lock against the repository to ensure that we only generate one release at any given time. If you want to use manual deployments, you can also simply add trigger manual to the step. This then halts the step automatically and only attempts to acquire the lock once the user tries to deploy the step manually. Now, one benefit of using manual triggers is deployment previews. Once you have added deployment to a step, the first visual aid we give is for manual or redeployed steps. Whenever a developer attempts to manually deploy a change or redeploy it, they are presented with a deployment preview page, as shown here. From this view, the developers can make a decision about if they want to deploy or redeploy the code by reviewing the commits that are going out or are being undeployed, or the code itself under the diff tab, or the Jira issues under the issue tab, or the pull requests under the pull request tab. This page, however, only shows contextual information for the current deployment and environment. The next visual aid is the environment dashboard for each repository, which gives you a bird's eye view of all of your environments and what is deployed or is deploying to each environment. This is used by developers or managers to see what is deployed or deploying. It's also used by support ops engineers to see the history of deployments to aid in diagnosing issues in particular environments. From this view, however, you can also trigger certain conditions, such as developers and ops engineers. Once they find which development introduced a breaking change, they can trigger a redeploy from this page to roll back code in a particular environment, as shown here. Or developers and managers can, for deployments that are manual, promote them through the environments manually. Something that I've mentioned a few times now are redeploys. Redeploys are a feature of pipelines that allow developers to roll back changes to an environment once a broken change is detected. Developers use the environment dashboard discussed previously to investigate the history of deployments to find the change that deployed the broken code. They then can select the early deployment to redeploy, thus rolling back the broken code. And when they attempt to trigger the redeploy, they are presented the deployment preview just shown, which now shows the subtractive changes rather than the additive, so they can make the best decision about which code to redeploy. So we've discussed tracking previews, dashboards, and redeploys. The final feature of deployments are permissions. Similar to merge checks, deployment permissions are certain conditions that can be configured per environment to ensure that certain conditions have to be met in order to deploy to said environment. Pipelines uses deployment permissions in two ways. The first is which branches can be deployed to a particular environment, such as only main can deploy to production. This, coupled with merge checks, ensures that only code that is peer-reviewed and with green builds can be deployed to production. And the second is deployment environment variables. This, coupled with which branches can deploy to a particular environment, you can now lock down certain credentials for certain environments to certain branches and environments to ensure that they're only exposed to steps that require them. One final option there, which we don't use but is available, is you can also allow admins to only deploy as well. Permissions coupled with deployment tracking and all the pipelines features mentioned previously and merge checks allow us to have a compliant, secure, and correct CI/CD pipeline. Overall, we have come a long way in improving our development process over the years with Bitbucket Cloud and pipelines. Our engineering teams currently deploy multiple times per day, and our deployment and rollbacks happen within minutes. This has definitely helped scaling our engineering and reducing time to value for features and mitigating customer impact during incidents. However, we strongly believe DevOps and CI/CD is about continuous improvement. So there are some areas we are investing in over the next few months. The first is we want to improve our own CI/CD speed, such as having faster builds, tests, and deployments. We want to improve our CI/CD quality by measuring and reducing test flakiness that happens occasionally. And finally, we also want to improve visibility around engineering metrics per team, such as deployment frequency, cycle time. These are really interesting metrics to help teams measure and understand their own bottlenecks, which they can then improve. I'll now hand you back over to Ash.
Thank you, Nathan and Graham. Before we move on to Q&A, I just want to point out that in the resources section of the webinar window, you see some links to demos, some migration resources, and a link to our public roadmap. All these links will also be emailed to you later this week. And with that, we'll move on to Q&A. So For the Q&A, we also have Patrick Wolf on the line, who is a senior product manager. And if you'll have any questions for any of us, please enter it into the Q&A console, and we'll take questions as they come in. And we'll answer what we can live. If you don't get to your question, we'll compile the answers, and they will be emailed out to all attendees in a few days. So first question is, so why do you use YAML? Nathan, you want to take that?
Sure. So we use YAML as a declarative format, so it's easier to have reproducible builds, so you can kind of specify your actual plan in a static way, and then your plan can change based on pull requests as well. So now if somebody wants to change how you release the production or what your feature branches are, you can raise pull requests to change it, and you have a static definition. We chose that over UIs because it's a lot easier to manage as code itself rather than having a screen where there's buttons and inputs, kind of like in Bamboo in the traditional sense. So yeah, it's a lot better to have a static definition for your CI that's like you can then use to reproduce your builds, because you can have a look at it and determine exactly what's going to run based on that.
Also, just to add to that, it's more succinct format than JSON or I guess XML or other sort of legacy formats, and it's more human readable for anyone that's building out the CI pipeline.
Next question, are there any resources regarding setting up Bitbucket pipelines for build using game engines like Unity or Unreal Engine?
We don't have any plugins for Unity or Unreal. I know Unity has its own CI system that they actually host themselves. In saying that, there's nothing stopping you from running the actual build within pipelines itself. So you can install all the tools that you need for Unity into like a Linux container, or if you're using a Windows runner, you can also do the same thing. You can run the build on Unity there, same for Unreal as well. So you can still script it to interact with the tools, but we don't have any particular plugins or integrations with those, no.
Next question, are there any plans to introduce package hosting, NPM, Nugget, Python, etc., as seen with GitHub and Azure DevOps offerings?
One for you, Patrick.
Patrick, I think you're on mute. We can't hear you, Patrick. Patrick, we can't hear you, so let's move on to the next question.
Can you hear me now?
Yeah, we can hear you now, Patrick.
Sorry, we've had this conversation of having package management, but right now we don't have any concrete plans for it. But if there is a ticket on Jira.com, please update there, and we will do that. And it is something we have considered for the future.
Next question. Our org is currently using Bitbucket Server, but will be migrating to a cloud provider within the year. What sets Bitbucket Cloud and its pipelines apart from GitHub or Azure DevOps, other than the Jira integration? I will start this off by saying that the Jira integration is also available for GitHub and GitLab as well. In terms of the Jira integration inside Bitbucket Cloud, you have a Jira UI embedded in Bitbucket Cloud, and you can interact with your Jira issues inside Bitbucket without having to go back and forth between tools. Nathan, Graham, anything else to add on the pipelines versus action side?
Yeah, so pretty much the only difference is like we have a lot of other integrations, not just Jira integration. We have integrations with JSM. So we have an integration that allows you to do deployment gating. So you can actually raise a ticket whenever you're about to do a deployment to production and get a historical view in Jira of every single deployment goes out. And then you can use Jira automation to either approve or disapprove, allow or disallow deployments to production if you want to do that using automation. And we've got other features in the future too that we'll be running integrations with Compass and with Ops Genie as well.
Next question, is it possible to secure code deployments so they can only be performed using hardware security keys such as YubiKeys?
We have no integrations for that, and because we believe in continuous deployment, usually if you would use a hardware key, it also requires a user intervention because it requires somebody to actually click a button or to approve it. So we don't have anything today. We could potentially in the future, if you're not using continuous deployment, actually have a check for that, have some kind of like pre-deployment action. We don't have anything today but for that.
What's the workflow for projects with multiple Git repositories? How do you do versioning, branching, CI/CD with multiple repos?
Pretty much the same as you do with a single repository. So Bitbucket Pipelines is 18 microservices and 40 libraries, and which means we have about 60 repositories altogether. And we manage them all exactly the same. So we don't do anything within a single, we don't do anything across all the repos. We have the same processes for every repo. So if you want to make a change to a service or a library, you go to that repository, you raise your branch, you create the branch, do your changes on the branch, run your tests, raise your pull request to master and release it. And so the services have the same deployment pipeline and the libraries have the same deployment pipeline. There's two separate pipelines because the libraries don't go through to production the same way because they're not actual running services. But we use the exact same process for every single repository.
Yeah. I'll just add to some of Nathan's points there. So in the presentation, we were talking about repository lines for our projects follow the same pattern, and each will clone this shared scripts repository, which contains which centralizes our sort of build and release scripts. So we can make one change there, and that change will fan out to all of our other repositories. It just centralizes how we do our builds and releases.
Yeah, we also, just in regards to versioning, so every single library and service is versioned individually. So all of our services are like 1.x, 2.x, 3.x, and our services just use an incrementing number because we don't really have a 1 and 2 for our cloud services. But what we do is we have a centralized BOM. So we use because we use Maven as our build tool. So we have a bill of materials file which has all the versions of our libraries in it. So usually what you do is you'd release a change to a library or a service, and then you go to the BOM and you bump the change in there. And then we go through each individual repo that has a dependency on that and bump the BOM. And that way we have one place where it says what all our current latest versions are, and then everything uses the same BOM file then for versioning.
Next question, can you define the difference between a pull request and cherry picking? I've read the documentation, but if possible, please clarify a little bit more.
Yeah, so cherry picking allows you to bring commits across from a different branch into your branch, where pull requests are actually a development flow within Bitbucket itself. So pull requests don't exist to Git itself, where cherry picking does. Cherry picking is a feature of Git. What pull requests are is a feature that Bitbucket provides around Git that allow you to say, okay, this branch is locked down, like let's say master, main, and then you want to raise a pull request across to it. You have to create a branch and actually create the pull request, and then that kind of is a designation to other users that I would like these changes merged into master. which is essentially similar to cherry picking, except it actually has a review process now because you can't merge those changes to main unless somebody actually approves of them.
Will Bitbucket Cloud BCMA support migrating repo SSH access keys in the future? Patrick, you want to take that?
At the moment, we don't have any plans for that. That's an interesting idea. But one of the issues with SSH access keys is that they are managed by the users, not by the organization or the workspace. So it's kind of up to the user to add their own SSH keys there, since the user owns that key, not the organization. Even managed users right now, that's part of the user's profile.
Does the CI/CD pipeline integration work with WP Engine staging prod dev servers? If no one has an answer, we can get back to you all via email later. I'm a newbie using Bitbucket pipelines. I just want to create a simple pipeline that will zip up my current doc repo and then SFTP that to a site host. This is an initial step to be able to trigger on a commit, having a pipeline start an SSG build of our latest doc website with the new repo info. Can you give pointers on doing this for a newbie?
Yep. So we have a pipe, like an SFTP pipe that you can use to actually push across changes to servers. And then you can just run, like the build container, you control the main script container, so you can zip up the entire contents of the repo and then use the pipe to go push it to an SFTP server. There are links to that within the pipe marketplace.
What knowledge?
With that too, sorry.
Go ahead, Brian.
I was just going to add, so you're also in control of the Docker image on which your build will run. So if there's any tools you need to support your build, whatever service you're deploying to, you can install those. You're free to install those tools yourself. If you need to, I guess, generate some sort of archive in a specific format, then you're free to add those tools.
What knowledge is required to set up a pipeline's CI/CD? How big of a lift is it?
So you would definitely need knowledge of your development process. It is today, like what are the actual tools that we use to run your tests and whatever you're doing like today in your current CI system. You'd also have to have operations knowledge to know about, like, when I merge to staging, these are the things that need to go out, or the changes I need to make, or when I merge to production, the same thing. How big is the lift of it? That's all dependent upon what your current pipeline looks like, if it's scripted already or if it's hard coded, or is it it all depends on what your current development process is really and how big of a lift it is.
Is it possible to pass parameters to anchored deployment steps apart from the basic dev, staging, and production deployments? Example, a scenario for our team is to run the pipeline for different environments and Azure regions as we have to specify the regions,
We have deployment environment variables that are linked to a particular environment, like dev, staging, or production. So you can set individual variables that are only available to those steps on those. We don't have variable sharing as a feature yet. That's something that we will have in the future. If you want to generate variables earlier on and pass them to the next step, that's something that we're definitely working on. But if you want to do it today, you can set, like, if you have like different regions, you can set those as variables against production or against dev or against staging. Yeah.
I'm also a newbie, and wonder where is the best place to look for resources help with Bitbucket Cloud features we may be using or trying for the first time. So with this one, we do have a link in the resources section linking out to a YouTube playlist of our demos. If there is a specific help that you need and you don't see it in the documentation, also just post a request on the Atlassian community, and one of us will get back to you with instructions or any information that exists on the site. I think that's all we have. If you have any more questions, we have a few more minutes. If not, we'll call it a day. Let's give it a minute to see if any more questions come in. We have one from earlier on. What is the best practice and step process to use when having to create a new feature to do bug fixes when getting code from the main branch?
I need more information about what they mean by step processes, because I think there was a question right before that, which is about what's the best process for creating new features, whether it's from a branch or cherry picking. Is this one in regards to what you do within your pipeline itself? I'm not sure what they mean by step process.
Regarding multiple Git repositories, do you have pipelines that do the CI for testing the integration between services components? If yes, how are they triggered?
Yes, so as we said, each of our feature branches, we run all the unit and integration tests. That's where we actually run the tests against the individual code and we mock out our dependencies. So if we rely on a service, we have a mock for it that we can run locally and within our CI system. We also then have testing on our main branch just before you deploy to staging and just after you deploy to staging and just before you deploy to production, that then test the real integrations between the actual service components. So we actually have a real test that tests an SQS event is fired and received, or we have a real test that tests the artifacts or caches are uploaded or downloaded, and they're run automatically on our main branch builds.
With that too, so we also have an integration environment where we deploy our services. So we have live services running in like a test/integration type environment, and we'll run scheduled pipelines continuously against that environment, which execute a suite of tests. So we use that to test integration between our live running services.
When will the below ticket be resolved in regards to deployments? There's a bcloud link on here, which is about allowing custom variables to deployment environments. Patrick, do you know?
I don't know on that particular, but yeah, I don't know if you've looked at that at all yet, Nathan.
I'm just looking at that at the moment. Yeah, so once we have variable capture or sharing, that feature would definitely be something that we would then allow, because then you can actually set the variables in a previous step and use a different value. We don't support that at the moment, but
do you have any resources on enterprise level management of Bitbucket, such as user provisioning and workspace project management?
Where's that?
Yeah.
So we are working on integration with Admin Hub, which is admin.atlassian.com. Will tie us into access for all user provisioning and workspace product access. So like Jira and Confluence, you would be able to define product access groups for Bitbucket, and any user that gets added to that group would automatically sync into Bitbucket. We're hoping to have that out in the next year, within 2023. It is a major overhaul for Bitbucket, but it's something it's probably our largest investment for the year overall in Bitbucket, is getting to that level of enterprise user management.
There's a question here from Saumya. Would you mind posting this on the Atlassian community? It might be easier to get a response from there. We use Bitbucket to manage OpenShift cluster state, Argo CD, to feed container image code into our CI/CD pipeline. What is Atlassian's commitment to support Kubernetes-based deployment models with Bitbucket pipelines? Also, does Bitbucket Cloud support Terraform state execution against, for example, AWS?
So we have pipes on our marketplace that integrate with Kubernetes, so you can deploy to Kubernetes clusters and deploy whatever you need to do, run deployments, run a pod, run a job, whatever it is you need to do. We also have, I believe, a Terraform pipe. I'm just finding the links to those now.
I think that's all we have time for today. If you have other questions, just post it on the Atlassian community, and one of us will get back to you, or we'll hear back from our users who can help as well. Thank you all for listening, and watch out for an email from us with a few more resources for you all in a few days. Thanks all.